people have always wondered about the structure of our universe. What is the true constitution of the heavens? Where is our place in the universe? What is the nature of the numerous swarms of stars that we see above us? Using telescopes, astronomers discovered that there are many more stars in the sky than what we can see with the naked eye. Billions of them. They are all members of our stellar system, our galaxy. Scattered among the stars are numerous extended fuzzy objects called nebulae. Just a few of them may be seen with the naked eye, but there are countless others that can only be seen on long exposure photographs.
The nature of nebulae and their place in the scheme of the universe have been favorite subjects of controversy since the dawn of telescopic observations. Some believe them to be moderately small and relatively near, scattered between the stars that we know. Others consider them as comparable with the galactic system itself, far and large island universes spread throughout the remote depths of space. The great philosopher Immanuel Kant argued that the universe was made up of many such separate islands of stars. Philosophers have debated the validity of that hypothesis. But astronomers took little part in the discussion, preferring instead to study these objects. The crucial question was, how far away are the nebulae?
No one was able to answer that question before Hubble, for even in the best photographs, the nebulae look like smudges of light, with nothing visible to study or measure. But Edwin Hubble had an advantage that no one else had. He began the study of nebulae with the newly built 100-inch telescope at Mount Wilson Observatory. In 1924, it was the largest telescope in the world. The mirror in this great telescope is 100 inches, or 2.5 meters in diameter, and it collects so much light that one can see stars that are 100,000 times fainter than the faintest stars visible to the naked eye.
I devoted my attention to the brightest, biggest spiral nebula that can be seen from the northern hemisphere, the Andromeda Nebula. Named for its location in the midst of the constellation Andromeda. Away from city lights, this nebula can even be seen with the naked eye. I centered the telescope along the outer arms of this spiral, and for the first time, photographs revealed hundreds of resolved stars. This opened up a new field of investigation. The study of individual stars involved in a spiral nebula. The nights were long and cold, but the results were spectacular.
By comparing photographic plates taken on different nights, Hubble noticed that some of the stars in one of the spiral arms showed a periodic change in brightness. This was the characteristic of a very special type of star, called a Cepheid.
My photographs of the Andromeda Nebula showed that the Cepheids that I found were of the same type found by other astronomers elsewhere. The brighter Cepheids had longer periods, while the fainter Cepheids had shorter ones. This was the well-known period luminosity relation that was discovered by the Harvard astronomer Henrietta Leavitt.
There was only one difference. Miss Leavitt studied Cepheids in another bright nebula known as the Small Magellanic Cloud, and they were all brighter than the ones Hubble found in Andromeda.
The period luminosity relation is clearly shown in both graphs, and the slope is about the same, which means that we are looking at the same kind of stars. Since all Cephids in Andromeda are fainter than those in the small Magellanic Cloud, it must mean that the Andromeda Galaxy is farther away. But by how much? If we imagine that the small Magellanic Cloud is twice as far away, it will look half the size, and its stars will be 4 times fainter. For the Cephid stars to match the faintness of that same type of star in Andromeda, the small Magellanic Cloud should be 15 times farther than it is now. This means that the Andromeda Nebula is 15 times farther from us than the small Magellanic Cloud.
Distances on galaxy scale are so vast that Earth-based standards, such as miles, are not convenient. Instead, we use light years, a light year being the distance that light will travel in 1 year at the speed of 186,000 miles per second. To illustrate, it takes light from the Sun about 8 minutes and 20 seconds to reach us on Earth. In 1 year, light can travel 63,000 times that far, but this huge distance is just a small scratch on the scale of our galaxy. Our Milky Way galaxy is about 100,000 light-years in diameter. The Magellanic Clouds are about 1/5 the size of our galaxy and about 1.5 diameters to 2 diameters away. The Andromeda Nebula is a distance of 2.5 million light-years, about 20 diameters of our galaxy away. Its true size is roughly twice as big as our own galaxy and 10 times larger than the Magellanic Clouds.
Thus, we discover that the same kinds of stars are found in remote nebulae as those found in our own neighborhood. This offers a means of exploring the space outside our galaxy. Other nebulae appear to be stellar systems not that different from our galaxy, only much farther away. The number of galaxies in our universe is enormous. If you stretch out your arm, the area of the sky covered by your thumbnail would contain up to 100,000 galaxies. Each galaxy could contain billions of stars, and the distances between the galaxies are even larger than the galaxies themselves. Immanuel Kant's vision was correct. The universe really is filled with separate islands of stars, galaxies.